Welcome. This is a recorded session of the Post-Quantum Cryptography Conference of the PKI Consortium, which took place in Kuala Lumpur, Malaysia. This conference is made possible through the support of the PKI Consortium Post-Quantum Cryptography Working Group and our sponsors SSL.com, Entrust, Keyfactor, HID, and Crypto-4A. And with exceptional organizational support from SSL.com, Keyfactor, Logius, POS Digicert, Baker Tilly, MSC Trustgate, and Digitoris. Join the discussion. Join the PKI Consortium. Go to pkic.org/join.
Good afternoon, everybody. If you're thinking about taking a seat, do it. And I don't see Paul to give me the green light, but I'm going to just take it. We're green, green, green. Hi, everybody. My name is Blair Canavan. I'm just going to stand over here on the stage. Sen's telling me. See, I don't know what I'm doing. There we go. How's that? Perfect. So thanks for staying. I know a few people are looking to, grab a beverage afterwards. So thanks again for making yourselves available. Again, this is one of the, I think, more interesting sessions that I've certainly moderated today. Oh, it's actually the only one I've moderated today, so let's make that clear. But I wanted to introduce you to your next speaker. If you haven't had a chance to look online to see who you're going to see in a moment, he's already put the bio up there, so it's not like I have to do a whole lot. But Ganesh is a 15-year veteran of AppViewX. And I snuck that out of him just a few minutes ago. And for those who've known AppViewX, that puts you in the first 20 employees. So he's a self-prescribed and probably more than self-prescribed evangelist. So near and dear to my heart on the very subject here that we're going to hear about. And he promised me that he's not going to talk just about certificate lifecycle management. He said he's got a whole lot more to talk about. What I'll just say is that this also means that for people like Ganesh, he's a member of the CA Browser Forum. He's a Harvard certified cybersecurity strategist, and he's a trusted advisor to organizations on PQC and digital trust infrastructure. So I'm hoping you'll get as much as I'm sure I'll get out of this, and look forward to hearing your questions, and feel free to do so. So Ganesh.
Thank you. Well, that was a very, very warm introduction. Thank you, Blair, for that. And good evening to everyone. Now I understand why everyone was saying the light is so bright on the face. It's really, really bright. And thank you for that. Well, last 3 days, right? The workshops, day 1 and day 2. I think we heard quite a bit of quantum. And trust me, since my childhood, I heard about quantum quite a bit. From none other than Sheldon Cooper. Ring a bell? Who is it? From where? The Big Bang Theory. Yes, right? Quantum physics. Well, only it comes to reality in last 2 days that whatever I saw in my childhood, which was fiction, we were all living that as a reality, because guess what? Now it is coming into the reality to put our encryptions, put our data at danger, not just the Schrodinger's cat who will be missing, maybe because of quantum physics, right? So with that introduction, good evening, ladies and gentlemen. I'm Ganesh Malya from AppViewX, and the rest of the introduction, Blair gave it. Yes, I am Distinguished Architect at AppViewX and a member of CA Browser, and working with Sven and a few other folks in IETF forum for ACME device attestation. That's a quick introduction about myself, right? So let's jump right into it, right? These are essentially the 5 pillars of things which we will be talking about, and many of the things which you will be hearing about from myself is going to be around hybrid PKI, which was a topic of contention in few of the sessions, including the last one, right, where it was discussed whether should we do it, should we not do it. Well, I'll try to ensure that why we should do it on that particular front, right? So we'll talk about the quantum threat, how near, real, and straightforward it is to hear, and all that. Well, right before coming over here to this particular conference, the first graduate in my family, the first engineering graduate in my family, trying to help my father understand, hey, Dad, I'm trying to go to this particular post-quantum cryptography conference, and I'm trying to explain a 70-year-old what is quantum cryptography, right? So the question he asked me is, But what's the whole fuss about this quantum? Because I'm hearing the news. Here's in India, SEBI, the Security Exchange Board of India, is giving a lot of mandates on how you should be encrypting, which couple of sessions yesterday, including Bruno and everyone, covered that there were some mandates given by SEBI. So I'm trying to explain him that what is quantum cryptography, right? And I did it in such a way he lost it completely, because I told him what we know today, which has encrypted all the data, right? I mean, the computers, what you have right in front of you, the data, it can be, the current computing system can use that particular data to break RSA in like what, 100 plus years, maybe, right? And I'm trying to tell him the new generation computers, not the Intel Pentium, no, the newer generation of IBM or any newer systems, which are cryptographically relevant quantum computers, may break it in maybe a day to a minute, right? But then his question was, then what's really the threat here? If they can only break in 100 years, and this computer, whatever you're talking, Ganesh, is not even existing today, which he's correct, doesn't exist today, it's still a theory, right? Yes, there are so many advancements happening, but what is really the threat? The answer was, to everyone's question, harvest now, decrypt later, right? And then Bruno in earlier session gave me one more talking point, right? Trust now, forge later, right? Thank you for that, Bruno, by the way, which kind of strengthened my own topic, right? On hybrid PKI, why should I even use that? So harvest now, decrypt later, essentially, there are actors we all know who are trying to essentially take our data. Sorry, there is no slide behind you, just PKIC's logo, but I can see right here. The data, what we are looking at is essentially all the sensitive data, which includes your financials, legal, healthcare. Talk to me about it, right? All the data is there, been extracted. There are reports that they are being extracted live, and essentially puts us into this particular multi-year migration path, which in last 2.5 days, I saw very similar slides to everyone. And I was sitting there and talking to Sven, dude, should I even do this presentation right now? Because everyone has spoken most of it, right? But yes, I mean, we need to, because this is a multi-year migration project for every company. This is not a single-click migration project because, yes, we understand the cryptographically relevant quantum computers do not exist. They are still theoretical in nature. But at the juncture of the end of 2025, there are certain advancements we as organizations need to do so that we can protect and understand where our data is cryptographically relevant. But the problem stands with all these applications, which is in my next slide, is there is not even a single click upgrade, just like how I'm doing a single click right now for my slides. That doesn't change my application stack or cryptographic stack in just a click of a button. Now, why is it that so, right? And that's an example I was really able to correlate with my father is, if I have to make a call right now to my dad sitting in India, there is so much of sandwiched layer of applications trying to come together to make that call, starting from my SIM authentication, tower authentication, billing desk, roaming, because now I'm in another country. So many of systems who are having their own encryption, cryptographic methodologies of decrypting, encrypting data, all coming in together to essentially make that call essentially possible, right? Essentially, this is not a simple migration or a transition we all will essentially go through, because again, you touch one system, you try to break something else, right? And again, going back to what one of my colleague, Murli, in his panel with CLM mentioned yesterday, right? It's kind of a Y2K crisis. January 1st, 2000, we knew Y2K would hit. But all we know here is what? MMDDYY. We don't know a dead drop date when this would really help, not help, will put us all in danger with all our data, right? So that's why essentially it's a one-of-a-kind multi-year transition across your software, hardware, firmware, and pretty much every application stack which you'll go through. And every application stack, when I mean starting from the top to the bottom, everything which uses encryption essentially goes for a toss, right? Now that's where essentially a little bit of blueprinting comes into picture. And this is one slide I'm pretty sure everyone has seen. I don't know how many documents, how many presentations, and guess what? I don't know how many times even in this conference today, right? Well, cannot emphasize this more, right? But I'm going to put this a little bit a different perspective in the terms of PKI in this, right? Yes, it's point understood that locating your cryptographic assets is the most important element in your PQC transition. We need to understand where your crypto assets are. But if you put the lens of PKI, it's important to know where your certificates are, keys are, and where they are deployed, right? So locating them makes it important. But from an assessment perspective, what can you do, right? I mean, you have your current existing PKI infrastructure, which runs on a multi-tier RSA encryption. What is the methodology you can move to? Because on the previous panel, everyone said you cannot move to a full-blown PQC algorithm-based PKI on day one. You cannot, right? Because if you try to move it, your application stack isn't ready yet to support the entire decryption of it, because when you put in PQC, your key sizes goes from this to brand new big size. So how are you going to handle it? There has to be an intermittent step in between for you to move, which in my opinion, and that is where a lot of these particular standards board are also working towards, is essentially in hybrid PKI. Now, we may debate this. Do we want to do hybrid, composite? Yeah, it's going to be a debate. It's going to be a long debate depending on your use case, essentially. Code signing is a totally different beast within itself, because code signing has its own PQC enablement being done by the CAP forums. So there is a lot of work happening on that front. But yeah, coming back to your application stack, the major question which I do ask myself when customers try to talk to me is the internet, and more importantly, your intranet, ready for a full-blown PQC handshake? Right? That's the most important question I try to understand, because so much of network elements needs to encrypt and decrypt the data at the same time. And your PQC full chain, say let's take ML-DSA 44, right, is around, what, 10,000 plus bytes? And don't think so every application in your stack is able to handle that, or even handshake do it. And that's where essentially Bruno brought in the point in his session earlier to trust now and essentially forge later. You are essentially trying to build an intermittent trust in between, so that tomorrow when the PQC or quantum reliable or reliable computers do come into picture, they essentially don't kind of break your existing encryptions. Now, what is hybrid PKI, right? Now, what are you trying to do with your hybrid PKI? It's essentially a mixture of bringing in both your classical and essentially your PQC algorithm. Now, in this example, I'm essentially using both the RSA and ML-DSA 44 in between to essentially sandwich to build out a hybrid PKI model in it. Now, if you put this into action, right, the key element with respect to the hybrid PKI comes down to two things, which is essentially your key sizes, right? Now, when your RSA stands at approximately 1,700, I'll just round it off to a bigger number, right? 1,700 on the web PKI, which includes your certificate transparency, including that, right? Your hybrid PKI essentially comes in, that is your intermediate layer standing at ML-DSA and 2048 of RSA, gives you approximately 8,000 bytes of a certificate chain. Any idea on how much is a full PQC chain? It's approximately 14,000 bytes. An entire chain, it's approximately around 10,000 plus or 14,000 bytes, which essentially brings up the question is, which is the migration path you'll go? But when, I think even Michael, in his presentation earlier, where he had a lot of examples from ING and various other organizations which they presented, one of the points which I borrowed from his presentation was, with a hybrid approach with the data, I think they did a composite, very similar to that. In one of the testings which we did here is, yes, the hybrid approach gives you 5x larger key size than the traditional or classical RSA, but is 45% smaller than your PQC algorithm. So keeping that in mind, your hybrid PKI still gives you an optimal or a balanced approach from a migration perspective. But two major things is your hybrid PKI gives you two things. One, it allows you to enable your existing application to work the exact same way they're working today, because your certificate chain has RSA and PQC algorithms embedded into it. And second thing, it essentially future-proofs you from a quantum threat, which means what? From a harvest now, decrypt later perspective, you are safeguarding your data today within hybrid PKI model from an encryption standpoint, right? So that is one of the main thing which we kind of understood from a hybrid PKI. Now, again, from an IETF forum perspective, there is enough work happening on using ML-DSA and RSA together. There are a couple of drafts in place, and there are a couple of drafts in the working group last call, which could see the sunlight at some point in time later this year or beginning of next year from a web PKI perspective, right? Now, essentially, when you do the hybrid PKI, this is a redundant text right here, which I've missed to kind of remove it. You will essentially see two different signatures and alternative signatures within your certificate. Now, this is coming from one of the active tests we did in the lab, wherein when you kind of mix and build a hybrid PKI, you get two different signatures within the same certificate, which means on the web browser, when you are doing a handshake, even though your web browsers like Chrome or Firefox, who are not actively supporting major PQC algorithms today, you still have the capability to fall back so that your application is still trusted by your browsers, and then you move from here. Well, that's where the next thing comes up, right? I mean, everyone is looking for a blueprint. I want a blueprint so that I can go and mimic it, just like what Sudha was showing in her slide earlier, right? If a company has a blueprint, can I just go and copy paste it? Exactly, no. But all they give you is exactly a pathway to go through. And that's where, when Murali was presenting yesterday, Fortune 1000, I kind of zoomed out or zoomed in bit and said, let's look at Fortune 100, right? Meta, earlier this year, one of my friend who works in Seattle, who's lead the cryptographic department there, they basically announced on the public wire, they are implementing and POCing hybrid key exchanges and hybrid TLS, which is on the PKI side of things, starting from January 1st. The same thing happening at Google. We all know it, Google Chrome, right? I don't know if it was Jaime, you on your slides where we had the security and privacy screenshots from Google. And the major three telecom providers in the United States actively POCing the implementation of hybrid PKI. So it's no longer a myth or a conversation. It is actually coming into blueprints, not for copy paste, to reference and look and implement within your organizations, right? Again, these are all three examples of early adopters who can give you a blueprint and then essentially walk the path of getting into the implementation of hybrid PKI, right? Now, the next question comes up is, again, this is again, I wouldn't say a redundant one, but from a hybrid key exchange perspective, and this is one of the points which Niels Gerhardt from UTMark was represented, right? 62% of organizations today are actively looking or trying to POC a hybrid PKI model, right? I had 60, but his data came out to 62, so kind of had to update in my oral text, right? And obviously 38% of website, which is one of the reference point I got from one of the active validations which happened recently, it's not 38 anymore, it's 42, right, are supporting hybrid key exchanges on the browsers, right? Now, everyone says 5 to 10 years. It's very aggressive in my opinion, right? 10 years to get completely ready for PQC, it's still aggressive because there is quite a bit of change you have to adopt to and get ready for it. Yes, you may get there to do a hybrid model of PQC deployment in 5 to 10 years, but I personally do not think so. Every organization is ready to get there to full PQC by the end of 10 years, which is 2030, 35, right? Where we have some mandates to get around with certain things, right? So why do we have to go hybrid, right? Now, when I Googled this for the very first time, right, to get an answer for myself, it gave me many things, right? It gave me even answers for composite certificates. Hey, you need to do that. But 4 things kind of stood out for me, and the third one is a very important one in my opinion, right? Is crypto agility, right? I'm just gonna harp on that particular point because running short on time for sure, right? So yes, but why do we get crypto agility trying to do a lot of classical fallback using hybrid PKI, right? It allows you to get into it's a middle step before you go into a full PKI or a full-blown PQC model. It gets you to an intermittent step so that you can move into a full-blown PQC at some point in time, right? Obviously, with hybrid PKI being deployed, you get to have to look into a lot of governance factors as well, compliances. There is a lot of NIST publications, NCSE is deploying, and they have also recommended a lot of hybrid mode of deployments and other assessments with respect to incident responses, right? Now, obviously, with the whole implementation of hybrid PKI and TLS-47 around the corner, these two migrations are happening hand to hand. You cannot be doing all these things with manual implementations. There has to be a zero-touch implementation with respect to automation, which you guys have to think about in the form of ACME. And it essentially leads the way with respect to automation is you have to ensure hybrid PKI works with every system to do a zero-touch implementation in an ACME. How are we doing on time, Blair? 1 minute. All right, fantastic, right? So yeah, again, building this Crypto-Agile PKI is all about 3 pillars in my opinion. One is modular architecture, which allows you to fall back into your classical and also look forward from a PQC readiness perspective, so that when your systems, your internal systems are ready to handle the full handshake of your PQC algorithms, you can still flip over into a newer algorithm. Obviously, there has to be real-time visibility, which goes back to the slide which we have been looking at in various forums for the 4 pillars of your crypto agility, which is to locate the observability factor, right? Even with the deployments of hybrid PKI, there requires a real-time visibility into your cryptographic assets on how they perform, what kind of data and performance do they give. And the final thing is automation with respect to ACME, which allows you to do faster, seamless, and agile deployments into the systems to kind of achieve it from a zero-touch perspective, right? And I'll quickly move on to the last slide, essentially just to remind everyone that this is not a marathon. Yes, we all said it's a marathon we are running, right? Yes, it is certainly a type of marathon we have to run through, but there are so many pit stops we have to stop in between to ensure and reflect back that we are doing this whole transition and updating our governance around these certificates in the right way. With that, I'll pause for any Q&A. If not, I would say, let's go and start it.
Great job, and thank you for staying on time. That was fantastic. In fact, if you even want to bring back the previous slide, I think that was a perfect ending. And do we have any questions from the room? I know we have one online that you want to ask Ganesh. Can't see. It's like being on stage.
No
here.
one.
No questions from the floor?
All right, well, let's just go to, wow, that's a loud microphone. Let's go to just online. So yeah, Ganesh, so why in the hybrid PKI setup you use an RSA only route? Doesn't that mean that the chain is still vulnerable?
It's a good question. It doesn't need to be RSA only route. It's an example with respect to what we had been testing in the lab. The RSA route kind of gives you a fallback mechanism from the current trust store perspective, because even the current trust stores, let's take your Mac laptop. The Mac laptop still cannot take an ML-DSA 44 certificate as a trust store route, right? So that gives you a fallback mechanism to begin with. Yes, if you ask me, is it vulnerable to begin with? Yes and no answer, because we still do not have a substantial data that RSA 2048 could be broken on today's date. Right? Yes, China is saying that, but we still don't know about it. But yeah, to the question, yes, it's a stopgap from a root perspective. But again, until and unless we have systems which can support a full-blown PQC's ML-DSA 44 root, that is going to be a stopgap until. That's the reason why we have intermediate, which has to be published across systems.
You are on fire. I don't want you to leave. You've got 2 minutes here. Let's use this 2 minutes. I'll give you this opportunity for the room, because you mentioned a couple people in the room, and you mentioned some of their slides and some of their things. Anything you want to share with the group that you've taken from the course of the last few days, and based on what you've been describing today, anything that jumps out at you you'd like to share with the audience, or lessons learned, or room for improvement?
Yeah, I mean, I would essentially say from a lessons learned perspective, 2 things, right? I mean, we are all talking about quantum migration, but yes, there's a lot of collaboration required, like what we were talking earlier, right? There's a lot of collaboration happening on the floor and happening in the industry right now between government, private sector, right? the siloed approach of how we essentially did the SHA-1, which took essentially 10 years for it to get out of, that is not going to cut this particular chase here, right? So that is one of the things which I actually saw in many presentations, which kind of stood out, that collaboration is going to be the key in this particular whole migration. And the thing, obviously, with respect to hybrid, right, which is everyone is talking, still up in the air. But yeah, that's those two things, kind of hybridization and kind of collaboration kind of stood out for me.
I think collaboration, I'm very biased in that. And I know she mentioned Bruno a couple times. If you'd like to get Bruno up here to do you want to thank him for all the pitches that he gave you? And Jaime, I know. No, you're all good. Listen, thanks again, Ganesh.
Thank you.
That was a fantastic conversation. Give him a round of applause.